Alright guys, so if you watched the last video, we did some setup for a gearbox, and we decided on two Falcons, a 9-tooth pinion gear, and an 84-tooth drive gear. So we're going to start off with just downloading the files we need and getting them moved over to the folder. So, like I said before, scroll down, CAD files, we decided on 84-tooth. You notice they have some with Versa keys and some without. The ones without are a little bit cheaper, and we're not going to utilize the Versa keys, so I'm just going to download the ones without. Like I said, my SolidWorks starts trying to open anytime I download a file. And then we're going to go over to gears, 20DP pinions. You got to make sure you use the same pitch gears, which is DP. They sell 20 and 32. If you're using 20-tooth gears, stick with 20-tooth. If you're using 30, stick with 30, or 32. 32 are going to be smaller. 20s can take a little bit more load, so that's why we're going to use them for our drive gearbox. And we decided on a 9-tooth spur gear. So CAD, 9-tooth steel, perfect. Falcon 500, that all checks out. And the other thing we're going to need for this gearbox is the actual Falcon, right? So motors, Falcon, we'll need just the Falcon for this little exercise. CAD files, download. Alright, so while that's loading, we can go ahead and move the files from our download. It's right here. Ooh. Oh boy, my SolidWorks is going to open on me now. But we can move this guy, and this guy over to the correct folder for us to be able to use it. Probably should have made a separate gearbox folder. If you're following along, I would suggest making a separate gearbox folder so you can keep your parts separate. I'm going to go with it. We're going to go ahead and open. You'd think I'd start with a part, but I'm actually going to start with assembly so I can get some of my dimensions going. I'm going to place our two gears we're going to be using, so our 9-tooth. That can get placed. And we'll go ahead and ground that for the sake of concentricity, and then we'll place our 84-tooth gear. Quite a bit bigger, right? So that's one thing to consider with this gearbox, is if I measure from that point to this point, which looks to be about the furthest, it's about a 4.3-inch gear. So if you're wanting to use this gearbox with 4-inch wheels, you can't, because the gear's bigger than your wheel. And we'll have about 1.5 inches of ground clearance, which I'm going to call okay. I prefer a little bit more, but it'll work. Now what I'm going to do is I'm going to constrain this face and this face to be flush, and then I'm going to get zoomed in on this gear tooth profile, and I'm going to line it up by hand, so that I can see how the gears are meshing, make sure they're meshing well. You don't want it jammed in like that, because there's no way that's going to assemble, and you don't even want it jammed in quite so tight. You just want it in to where you can see there's not a lot of gap, to where there won't be very much backlash, but there's enough gap that you're not going to chew teeth. That being said, if there's too much gap, you'll end up chewing teeth too. I think that looks pretty good right there. You can see it'll mesh in. Everything looks good. No interference. And then once we have that, we're going to measure from the center here, that is actually a radius, I'm not insane, to, oh, I clicked the wrong thing. So from there to the center of that, so center, 2.347. So now we can do the part. So make a part, leave that assembly alone, leave it there, leave it how it is, that way you can come back to it. I'm actually going to click on this and ground it, just that way I know it won't move. Right now I didn't actually ground it. Great, just Control Z, ground it, so now I know it won't move. This won't move, it'll stay right where I want it to. And then for my gearbox, I'll start a 2D sketch, go to a 2-point rectangle, which is what we're used to using, and I'm just going to make like an 8" by 8" plate. This is what we're going to start off with. It's ridiculously big, but that's okay. So I'll finish the sketch. Extrude. Yeah, that's fine. Oh wait, no. I'm going to do a 1/4 inch thick, and then we can start laying out some dimensions. So I'll start a 2D sketch here, and I'll do, first thing is going to be project the geometry of this bottom line so we can get centered, and do a point on the center of it, and dimension that up. I'm just going to say 1 inch. Looks good. Finish sketch, do the hole. This is going to be where our big gear goes. It's going to hold our wheel and everything. Our drive gear, our wheel will connect to this, everything like that. And then we're going to start another 2D sketch here, projecting the geometry of this circle. And I'm just going to go ahead and draw a circle on here. I'm not going to put a dimension on it yet because I'm going to snap back over here and find the dimension I need. So I'm going to do that same measurement I already did, just to make sure I remember it. So here to here, 2.347. Right, so that's what needs to be the difference from the distance from the center of this hole that we just made to the center of where our motor's mounted. So, coming back to our part we're working on, we can dimension from here to here 2.347. Right, that is what it was supposed to be, I believe. It's important that this is right, so I'm going to double check it again. 2.347, right? 347 plus match. Cool. We are good. So now I can mount my motors anywhere in this in this circle. So I'm going to just throw a point onto that circle and dimension in from here. We're just going to call it 1.5. And then I'll do the same thing on the other side. Now it's important to make sure your motor will actually fit on the material, and that's why I'm doing this 1.5, because the motors are a little less than 3 inches. We can double check that, and it's not that hard to come in and edit it later, so I'm not too worried about it, but you want to make sure it's right. So now we can finish sketch, do a hole, and so now I can either open the CAD, or if I come over here, we're on the Falcon 500 page. They have these drawings on their website. Falcon motor engineering drawing. Cool. So you can see this has a bunch of very useful dimensions. Like you can see this one right here, the outside radius of the Falcon, the little piece that sticks out is 0.75. So ideally I would be able to machine that perfectly and do 0.75, and it would snap in and index and be great. However, I found that ultimately, when I try and do them just perfect like that, they end up getting drilled through anyway, and more torque and torsion gets transferred to my motor mount screws, and I'm just going to go ahead and accept that in this. I know it's not best practice, but that's what we're going to do. So 0.875 gives me an extra 1/8 inch of clearance. I have battle tested this method and it works. I acknowledge that it's not the best. So go ahead and enter. Now we have these holes. So we can see we have these, but how are we going to actually mount our motor, right? We're going to do another 2D sketch. And then we will project the geometry of these guys, and then we'll come in with a circle. Now from that drawing, I happen to know this, but it's a 2-inch circle that the bolt pattern on the Falcon follows. And then what I'm going to do is I'm just going to come in and do a hole right off the bottom, right off the top on both of these, and that'll allow me to mount my motor. The Falcon actually has 8 holes. I'm going to throw a couple extra in here. You can decide which ones you want to use when you mount the motor. More might be useful. Generally, we end up using 2. That's been fine. They have 8, and you could technically use 8 screws, but they also serve as ventilation holes. So I'm going to go ahead and put 4. We can put 3 screws in it if we want, because this hole right here is going to be kind of hard to access once we get our big gear in here. So just going to go ahead and finish that sketch. Do a hole, 0.2 inches. That works for the 1032 screws, I find. So now we have our motor mounting holes, this hole. Now all we need is a way to mount this thing to our rail. So yet again, another 2D sketch right here. And we can come in and say a point. I like to mount them with 1/4 inch bolts. I find that it works. Some people use different things. 1/4 inch bolts work for me, so that's what I'm going to stick with for this tutorial. And I'll dimension up. I'm going to go 0.375, just because I like that. It gives enough bite around the bolt to make it hold, but it doesn't go too far into it, and allows me to spread my bolts out a little bit more. Dimension up from this guy. Do 0.75. I'd like to have them a little further spread out, but I don't want to get too close to this motor that it becomes an impossible bolt to tighten, right? You want to be able to actually get the bolt through the hole. And we can always come back and edit these later. But for now, these will work just fine. I don't know where that went. Oh. That's better. I don't know why I typed in 375 inches away. It doesn't really work for us. So we can finish that sketch and then say hole 0.25 inches. There you go. Now we have mounting holes and everything like that. I'm going to leave this video here. On the next one, we'll come back in and we'll make some little 3D printed spacers to be able to space this off. And we'll start the assembly of the gearbox and start cutting out some of this excess material that we don't really need. And from there, we'll be able to continue on in the series. Thanks for coming.